Good morning, all of you. So today we will start with our fifth chapter, which name is Simple Machines. So in this chapter, we will discuss about what do you mean by simple machines, its types, and what are the efficiency of each kind of simple machines, and we can solve some numericals also. So first of all, what do you mean by simple machine? So a simple machine may be defined as a device which enables us to do some useful work at some point or to overcome some resistance when an effort or force is applied to it at some other convenient point. So you can see these are some examples of simple machine, like the wedge here. Then this is the example of pulley, and here a man lifting a stone with a lever. In all these cases, the force also applied and some work done also we can see in this figure. Now, what do you mean by compound machine? So a compound machine may be defined as a device consisting of a number of simple machines which enables us to do some useful work at a faster speed or with a much less effort as compared to a simple machine. So in case of compound machine, we can see there are more than one simple machines and the effort load and the work done can be carried out by various types of situation. So you can see these are some example of compound machine situation. Now comes to lifting machine. So according to the lifting machine, this is a device which enables us to lift a heavy load, which is denoted as W, by applying a comparatively smaller effort, which is denoted as P. So these are the machines by which we can show the lifting of any material. So that's why these machines are known as lifting machine. So this is the crane and this is the excavator. So now, in case of any kind of machine, it have two values. One is input and another is output. So first of all, input of a machine is defined as the work done on the machine. In a lifting machine, it is measured by the product of effort and the distance through which it has moved. Similarly, to find out the output of a machine, it is defined as the actual work done by the machine. So in case of lifting machine, it is measured by the product of weight lifted and the distance through which it has been lifted. Now, efficiency of a machine, which is most important. So efficiency of any kind of machines can be found out by the ratio of output to the input of a machine. So generally, the efficiency of any machine can be expressed by percentage, and it is denoted by mu. So mu is equal to output by input into 100. Now another technical term related to lifting machine, that is mechanical advantage, which is simply known as MA. The mechanical advantage is the ratio of weight lifted to the effort applied, and it is always expressed in pure number. That means the mechanical advantage has no unit. So mathematically, mechanical advantage or MA is equal to W by P, where W is the weight lifted and P is the effort applied. Then coming to velocity ratio. So the velocity ratio is simply known as VR, which is the ratio of distance moved by the effort to the distance moved by the load, and it is also expressed as pure number, and mathematically VR is equal to Y by X, where Y is the distance moved by the effort and X is the distance moved by the load. So here there is a relationship built up in between mechanical advantage, velocity ratio and efficiency of a machine. So in case of lifting machine, it is an important relationship which throws light on its mechanism. So first of all, we have to consider a lifting machine whose efficiency is required to be found out. So consider W be the load lifted by the machine, P be the effort required to lift the load, Y be the distance moved by the effort, and X be the distance moved by the load. So according to the definition, we know that mechanical advantage, that is MA, is equal to W by P, and velocity ratio, that is VR, is equal to Y by X. But as per the definition of input of a machine, we know that the input of a machine is the product of effort applied and distance through which the effort has moved. Hence, the effort applied is P and the distance through which the effort has moved is Y. Hence, the input of a machine is equal to P into Y. Similarly, according to the definition of output of a machine, we know that it is the product of load lifted and distance through which the load has been lifted. So here, the load lifted is given as W and the distance through which the load has been lifted, that is X. Hence, output of a machine is equal to W into X. So by the definition of efficiency, we know that efficiency, that is mu, is equal to the ratio between output to input. So here, according to this expression, the output is equal to W into X and the input is equal to P into Y. That means by solving this problem, we will get the W by P divided by Y by X. And this W by P is the value of mechanical advantage and this Y by X is the value of velocity ratio. That means here mu is equal to mechanical advantage by velocity ratio. Hence, the relationship in between the three terms, that is efficiency, MA and VRB, is equal to mu is equal to MA by VR. So as we know, the efficiency of any machine is expressed as percentage. So here we have to multiply 100 with MA by VR. Hence we will get the value of efficiency. So now there is a numerical. So here the problem is, in a certain weightlifting machine, a weight of 1 kN is lifted by an effort of 25 Newton, while the weight moved of by 100 mm, the point of application of effort moves by 8 meter. Find mechanical advantage, velocity ratio and efficiency of the machine. So as per the question, first of all, we need to write down all the data given. So hence, first of all, the weight is given, which is 1 kilonewton, and we have to convert this kilonewton value into newton. So 1 kilonewton is equal to 1000 newton. Then the effort load is given, which value is 25 newton. Now the distance through which the weight is moved, that is the value of x, is given as 100 mm, and we have to convert this 100 mm into meter. So 100 mm is equal to 0.1 meter. Then the distance through which effort load is moved, which is y, is equal to 8 meter, which is given in the question. So now we can find out the value of MA, VR and the efficiency. So as per the definition, we know that MA is equal to W by P. So W is 1000 and P is 25. Hence the value of MA will be 40. Now the velocity ratio is equal to y by x. So the y value is 8 and x value is 0.1. Hence the value of VR is equal to 80. So now we can find out the efficiency. So as per the relationship between efficiency MA and VR, the mu is equal to MA by PR. So MA value we got 40 and VR value we got 80. So 40 by 80 will be 0.5. And we know that the efficiency should be expressed in percentage. So that's why by multiplying 100, we will get the efficiency of this lifting machine will be 50%. So today this much. Thank you.